Welcome to another system designing project that we are going to learn today, and it will be a very interesting one. So the title of this project, as you can say, or the system, what sort of project we are going to design. We are going to make a simulation based on DC speed control system. Okay, we are just going to make a system which will be based on PWM operation, and it will be measuring the speed, which means how the operation of PWM can be done. So for that we need to understand how PWM actually works first. So let's proceed while making a new project. Okay, just like before, just like some other systems, what you're going to write is just the previous systems. If you go through the previous experiments, you already know the system. You need to just give a name for your project first. So let's give a name, for example, speed control system or DC speed control system. Okay, you can name it like this. And just give next, next, next. In here you will need flowchart, just like before. Just select flowchart and finish. Okay, so now we have our Arduino board. We are also going to use Arduino for this project. This can be done using Raspberry Pi as well, but for now let's focus on Arduino. So you need one display control, DC speed control. Okay, so speed control, you know, the system or the hardware usually used for controlling the speed is from this motor shield. So motor shield is a device. It looks okay, it's not in here, it's from the Grove. Sorry, you need to go to Grove section, and here if you search, no, it's not in here as well. Okay, we need to search in Arduino again. So you need to search some DC motors. Okay, if you go through the name of the system, it is basically DC speed control system. So here just you can scroll to find one DC motor. Yes, here actually it is in Arduino folder that you have. So here you can see some shields, motor party, or two-stepper motors, including two-stepper motors, but for our system we are going to include the DC motors first. So just take this DC motor, so it will take a little bit more amount of space. Okay, just place it. Okay, just left click and it will be placed. Along with that, you need to see use a controlling device for measuring, giving a specified duty cycle for this system. Actually what happens in PWM is the speed of the motor needs to be controlled by using one according to theory. Okay, according to the theory, what we can understand is we need one potentiometer, and also for controlling it we need one button as well. Okay, button system. Button means push button system. Okay, so that you can find from Arduino, just like before. Go to this button breakout board, just select this and open and place it nearby, anywhere you want, where you can control the system. Next is you need one display system for this. So just like before, we will go to the Grove section. Okay, just like other systems that we have been learning so far. Just like those, we are going to place one OLED display here. This display will be used for showing the speed of the overall PWM operation. Okay, what is the speed? This we can control later on. Control using this button breakout board, and also specifying some conditions in flowchart designing while we will be designing the flowchart. Okay, so now next part is potentiometer. We need one potentiometer. So if we go through this file and import project clip, there is no device like potentiometer actually. So what we will be using here, we will manually make the circuit for our potentiometer device. Okay, so just go to this component mode. It is already selected, very good. If it is not selected, just select it. So just go to this pick devices option. Okay, just select this. Here you will write potentiometer, okay, pot hg hyphen hg. So if you select, if you write or use the proper keywords, obviously your proper desired component will be available. So this one, let's say you want to place it somewhere here. Okay, just variable value. So since you're going to control this value right here, this will be the determining factor for specifying the duty cycle of the system. Okay, so what can be done for specifying it? You need some controlling devices, isn't it? Like one label, one input, okay, one something like that, one pin, IO pin you need to specify here. And IO pin means like since it is a PWM operation, so it will actually not be one IO pin, because if you use an IO pin, as you know, it is used for digital input output connections, for digital operations basically. But here, since it is PWM operation, it will be a continuous pulse width modulation operation, so obviously you need one analog input here. So for that, just go to this terminals mode. Okay, till now we were taking the components, pot hg, we have taken one component, we have used this component mode so far, but now we are going to concentrate and select the terminals mode. So here, from here you will get one default, one power you will take for VCC connection, okay, supply voltage connection. So let's take a power connection here. Okay, this is how you can connect it. Okay, and the connection is not correct, so I will just move it. I will place it here. Okay, let's just give Ctrl Z. Okay, so just take one power connection and connect it through this terminal basically, and you can rotate it. Okay, just use XY mirror for connecting it. So first connection for power supply is done. So whenever through any circuit or any component you're trying to design, okay, any device you're trying to deal with, what do we usually do? We take one ground along with our VCC connection. So just place the ground, and also as you can see the direction is oppositely directed. So what we are going to do is again take XY mirror and just connect these two components. Don't use double click, it was mistakenly placed. Anyways, just connect it. Okay, so the next is default. Default means you are going to labelize your IO pin or analog pin. Okay, for this case what we are going to do is take an analog pin, but in other of the circuits you have already seen how you can just give XY mirror, because it is along X plane. Okay, it is no longer on Y axis, it is in X axis direction. So just you can move it and connect it directly, or you can take another wire and connect it. Anyways, so now we need to labelize this one, which sort of pin we are going to take. Analog pin. Okay, analog connection. So let's take analog pin 2, AD2. Okay, any analog pin you can take. So for now I am taking analog pin 2. And let's see here, the digital pin is also connected, which is using one push button here. Okay, and about the resistance, potentiometer resistance value 1K is fine. We don't need to modify it anymore. So this is how your overall circuit would look like. Okay, so what we need to do is just make one, we can give a save for now. Those of you think that your software might softwares are stuff sometimes while designing it just crosses out or something like that happens somehow. Okay, before even doing the flowchart or designing work, on the halfway sometimes current goes away, electricity goes away. Okay, it's very common in Asian countries or maybe developing countries that electricity is still in some of the places in rural areas. It happens very frequently. So for those students or those who are in rural areas, where electricity hasn't reached that much, or I mean Wi-Fi or internet, broadband internet connections is not that much available. So for them, I would suggest whenever you're doing any work with any software, learning, practicing about it, it's a good practice to give save after each and every task is completed. So in this way, your file will be, at least you don't have to redesign your stuff again, redesign your system again and again. So at least our one part, which means circuit connection, is done. So we are happy about it. Now we can move we can move forward, okay, towards designing this setup. Okay, so now since you can see the diagram needs to be a little bit more visible for you so that you can easily complete this task, so I'm just making it more maximized uh, representation. Okay, so now what we are going to do, this is the setup part. So our first part, sorry, not this one. Okay, so our first task, okay, first part is setting up the components that you have taken. So first component is, you can go to this CPU. Okay, just select here. Here you will get pin mode operation. So you can see a list of operations are here, but we are going to specify some pins as inputs. So first input is when you have your, we just connect it first. Okay, then just double click here. Along with that, you need to specify some assignments here. Okay, so assignment block, we can take one assignment block and then specify some function or variables here. So which variables we are going to deal with. So as you can see from the schematic diagram, what we have taken IO2, which is input port, okay, controlling factor for our overall system. So we are going to just select here. Okay, select here. If you double click it, one window will come, something like this. So it is input. Obviously in setup portion we are going to set up our input first, isn't it? This is the main task while writing any code, any program. We need to, for regarding Arduino, okay, we already know, those who have worked with hardware, what do you have? You have loop function, void loop, and void setup, basic. But now since we are doing our algorithm or flowchart part, so for flowchart designing, what we can do is just specify the mode from here. Okay, from this input pin is our 2. Okay, just 2 select, you can select this 2 and it will be done. Okay, and initially since there is no connection, so just for initializing the system, what we are going to do is give a 0 here. Okay, for the first block, oh, you need to place one. Okay, okay, so one okay is activated, which means your pin mode block number 1 is also working as input, and the pin is 0. Initially it is 0, which means initially you don't have any hardware connected, but after, during the setup portion, what you need to do is specify that 2 pin. Okay, next is assignment. So in this assignment you need to specify some variables. So what sort of variables you might need, okay, and what would be the, if you select here, you can see nothing, no list or what sort of assignment you're going to place, which variables you need to consider for your system is not specified. So what we can do, we can just select this new and write one rot, okay, rot direction. Now you might have a question why we are using this sort of variable, because if you go back to your schematic diagram, you have already seen that we are using one motor here. Okay, 2 DC motors, basically motor number 1 and motor number 2 inside one motor shield. So if we specify our system PWM operation, for one case your motor will run, or the speed will be something like this, etc., etc., we can use some conditions for our system. So for that we need to specify our direction. So initially in the setup part, the direction of the rotation will be in integer. Why? Because it is initially 0. So since we are assigning 0 value here, so we will select the data type, variable type actually. Variable is rotation direction, ROT direction, okay, rot direction, and it is integer. So similarly we can take another assignment, but you can see already rotation direction is specified. So we are not going to take it anymore here, but in future we will modify it or upgrade the values to see some differences, or apply some decisions. Anyways, so next variable, what sort of variable can be used? In our system we have used one button, okay, push button. So push button, what sort of operation does push button do? Either it has switched on or switched off, right? So how does switch on operation happen? Whenever the switch is pressed, okay. So whenever the switch is pressed, your whole circuit would be activating, which means it will work properly, right? This is the basic criteria for any switch push button. So what we can do, we can write a variable as pressed, okay, and the variable type or data type can be boolean, because what we will be doing is, since we have assigned our variable, see, easily you can select your assignment from here. So this is how you can assign or declare some variables using assignment block. So here, since initially our push button is not pressed while doing the setup of our system, what we can write is false. But in future, while we will be giving our conditions, we will make the switch pressed also. So then we can select our options or conditions as true in the loop operation in future, okay, after some minutes. And next what we will be doing is giving another variable, assigning another variable, which is the state. And the state will also be whether the state is yes or no, okay. Yes or no, which also means boolean, which means true or false. Another variable you need, which is rotation speed. Now what we can understand from here, already the direction is specified. Initially it is 0, but in future while loop operation your direction will be varied, whether the motor will run in forward direction, clockwise direction, or anti-clockwise. This is supposed to be the usual case, isn't it? So along with that, you need to also specify the speed, because if we go to the title of our system, DC speed control system. So what we can understand from DC speed control system is, obviously we need to specify the speed of our rotation of motor. So just rot speed, and for the value of speed, it is obviously going to show in some values, integer values. So just OK. And initially what we can understand is the rotation speed is supposed to be, since it is not moving in anti-clockwise or clockwise direction is 0, isn't it? So what will be the speed? Speed will also be initially 0. So the next, another variable we need to specify, so we can just resize our box right here, so that after assigning it we can see here that what variable we have used. So since our overall system is associated with PWM operation, okay, so we will just write PWM and output, okay. So PWM, if you see, the values are usually in integer as well, so just keep it as integer and just OK. So this variable and state variable, these two variables are not required for assignment block, which means setup portion, but in future for defining some formulas, we will be using these two in the loop section, okay. So that's the reason why we need to assign it first. Before assigning it, nothing will be possible. So now we can proceed with the loop section. So now let's see what happens in loop. So for loop, you know, PWM operation is the case, so we need one analog read operation going on. We need to select that. So here if you see in CPU, one block is there, and analog read or pin mode or digital write or whichever functions you have used so far, those functions actually are associated with CPU block. So that's the reason why it will be available in CPU peripheral operation only. You will not get this sort of functions in any other, you know, peripherals like motor or button switch or LCD or any other ultrasonic sensor or any other sensor, you know, whichever sensor you are going to work with. Anyways, depending on your system. So anyways, here what we can, if we double click it, before double clicking it, okay, we can see the input pin is not defined. So just give a double click here. The input pin is 2, AD2. We have used AD2. If you go back to, just give an OK. Let's go back to the system designing. Here you can see for varying the potentiometer values, what we have taken AD2. So that's the reason why in analog referencing work as well, we will be using AD2. Okay. So the value, here the value is associated. This is the time when we will be introducing our PWM output. So here you can see PWM output already, because if we don't initiate it now, we won't be able to control it later on. Okay, later, which means here we are going to use another assignment block where we will be applying one formula for our full operation. Okay, in this sector we are going to place one formula. So what will be the formula? Let's think carefully or logically. What is the main target? Okay, main target is to calculate the speed, isn't it? The speed in which your whole PWM control operation, DC motor speed, is being operated. That is our main target. So we will be selecting which assignment, not direction, not press, not state, etc., etc., nothing like that. We will be only selecting our rotation speed, and here we will write a formula. So what is the formula? The formula is, we are going to take one function here, okay, floor, and we are going to write inside the bracket, we are going to give another bracket 0.25. I'm explaining it, so stay tuned with, just wait for it. Okay, PWM output. Okay, this will be actually our overall formula. So you can use double bracket like me, or one single bracket as well, perfectly fine. So how it is going to work, how this formula is going to work, okay, you might have a question in your mind. Basically for PWM, what happens is, you may select, if you divide the whole system into clock pulses, okay, into time periods. So how does the system work? It gets two situations. Okay, one situation is if you divide the whole clock pulse into two states. One state is when your system will be on, another state is when your system will be off. Okay, so we are going to calculate the time, the speed when your system will be on. So for our case, we have just taken 25% of the time, which means your system T on, okay, time on, you can say your system is on for only 25% of the time, which means 25%, for 25% you have taken 0.25. That will be more clear after the overall flowchart is done. So just I am going to give OK for now. So this is the formula that you are going to use. Next is, you need to show this formula. After completing the formula, you need to show this value in one display system. So what we need to do is select one subroutine call. If you double click here, you will get only setup and loop, but we need to operate the display system. So what we can do, we can take another event block just like before, place it somewhere nearby, name it as display. What you are going to display? For our system, we are going to display speed, isn't it? So just write display underscore speed. You may give space here, but space doesn't work. If you try, space doesn't work if you want to have a gap in between two words, you can use one underscore here. Okay, instead of underscore, if you just write it along without using any space, that can also be okay. That's totally up to you. You know, your design is up to you, how you're going to do it. So as you have assigned one event block here, what is our target? Our target was to call the display system, isn't it? So now automatically your method has upgraded. So you need to give OK here. So this is one part of our loop operation. So now let's proceed. Now as you can see, let's go back to the schematic. Okay, as you can see, we have two inputs. One is analog read operation, which will be basically responsible for varying the duty cycle, duty cycle of the system. Along with this duty cycle, after simulation, what you will be seeing is, if I give simulation here, then you will be seeing that overall system. Okay, can I? Okay, what I was trying to do here. Okay, if I give simulation play here, okay, if I use the play simulation option, then your motor will run, and how it will run, that conditions we need to place first. And along with that, for controlling this motor, this analog and read operation for our PWM, duty cycle determination, varying the duty cycle values, is already set up as you have done in loop. Okay, analog read operation is already done, okay, but you know, you need to activate this button as well. So for button, as you can see, it is digital input, so you cannot use analog read anymore. So our next target is to activating the digital pin, which is button. So here from the name we will just take, as the operation must be, it is digital read operation. Okay, make sure that the connections are built up using the dot lines. Okay, just dot symbols. Okay, so just after that, what we are going to define here. Okay, our main target is to select whether your switch is pressed or not. So for that, we can take one decision box here. You can see easily yes or no comes, and you need to specify the pin here. Okay, so just double click here. You're going to use 2 and the condition. Okay, what condition is there? Instead of state, you will just select pressed. So this is how your decision we can move forward towards decision making. Okay, so now inside this decision, what can be our controlling factors? That is our main target, next target. Okay, next task to do. So what is our task? We can control one motor, or we can take two motors. Okay, so it is totally up to you. So I am taking one motor condition for this case. So let's take motor 1, and it is going to run, because this when the switch is pressed, the motor is going to run, but in which direction, that we need to specify. So let's take this run, just select it and drag it here. Okay, so we have taken forwards here. You can take backwards also, that is totally up to you. Another condition, motor will run in backward. Okay, just double click here, just select backward operation. And the speed, this speed is not actually 255. We are going to give ROT SPEED. Why? Because you are going to control or take some readings, okay, readings of the speed using the OLED display. So if you fix the speed to 255, you cannot actually operate the whole system. So for the both of the systems, whenever the decision, you need to specify the decision also, it is pressed. Okay, so just write pressed here. Okay, just by writing P, your press actually comes. So just give enter, select and enter. So here it is. Okay, so just double click it and just write what? ROT speed. Okay, just like before. You can also select it and just enter. Okay, anyways, And you know already that rotation, I mean forward or backwards, is already specified, so you can assign some delay as well. So I'm taking very specific small amount of delay. You can take different values for delay as well. Let's say it is in 100 millisecond. So now for fast output, you can minimize the delay also. But let's say you want to take in seconds, you can select from here. You can vary, you can play with the values. Okay, this is just the basic. I'm showing one example, so that's the reason why I'm not going to vary, vary the values actually. So that you can do it while you're playing with your system. Once you know the designing, you can modify your designing and make new projects, new nice projects for understanding your system more. How you can, utilize this knowledge for overall new system designing. Okay, new your own very own system. You can use some LED lights. You can also play with the LED lights conditions as well. You can use LED light number 1 for here will be on or off for the other case, etc, etc. Many different conditions can be placed to make your own circuit. Okay, it totally depends on you that how you're going to design it. So I'm just giving the basic knowledge, just showing you a system that how you can just make a basic one. So here our next target is to specify that how our display is going to work. So what we are going to do, go towards the display system. Okay, so here is our display. As you can see, so many functions are here, but you have used the display before in the other videos already, in the other labs or experiments examples already, in temperature control, temperature monitoring system, and another one was the previous one, obstacle detection. Already all of you have seen. So just we will proceed by following the same system, same categories, same functions actually. So here what sort of functions we can take? We can take the clear display one, obviously. We can take set the text color. Okay, what color? You already know, white. And why it is white? Because the OLED display initially is blue, but when you will be giving the simulation run option, then automatically what will happen? It will become black. Okay, so for black background, a white text or white output is obviously perfect. Just contrast values, you know. So next is set the text size. Okay, so how you can take one which will be, the value will be very small, but since we are going to only show the speed, we can take a bigger value, 3 or 4, perfectly okay. And along with that you need to set the cursor. Okay, so let's take a cursor here. Just select the coordinate, let's say 5 and 5 for now. You can also change the x and y axis if you want to. You can select print here for printing out the message. So what is the message for our system? Okay, for our system the message is showing the speed. So you will write, you cannot use message just like the other experiments. You will just write speed just give OK. And next is display. So I live in a Muslim country. Okay, so here azan is giving because it's time for prayer. So if you cannot listen to my voice, I'm sorry for that. But this is the end of our overall flowchart. So now let's debug it just like before, you know. Okay. And next is build. Okay, so you can see compiled successfully. Now we are going to go to the schematic capture and see what happens. So for using this, we are going to use one simulation system. Okay, so for simulation, okay, run simulation. Since the play button is not showing here, so just give run simulation. So now the controlling factor, okay, speed is 128. Why? Because, okay, let's see. So according to our flowchart, okay, according to our flowchart, what we have done, our button is not pressed, and if it is not pressed, it is going to, the motor is going to run. We have considered only motor 1 for this case. You can take motor 1 or motor 2 according to your desire. So it is going backwards, you know. When the switch is pressed, it is going to be what? Forward. Okay, you can see the direction is changing. Okay, you can see it is moving forward. And along with that, you can see the direction. Plus means forward. So as I have released the button, it is in minus. So if I press the button again, you can see forward rotation and it is plus. So this is how your motor speed for motor is going to work, but the overall PWM operation, consider carefully your potentiometer has the value of 50% of duty cycle. So the speed, overall speed is 128, as you can see, 128 for now. So you can rotate down, okay, just you can take some columns, data tables you can make, okay, one data table having first column as the value for your duty cycle, second column duty cycle you can vary from 0% to 100%. How? Why it is 100%? Let me show you. Since it is in percentage, obviously the highest value will be in 100%, isn't it? So from 50, let's try to see what happens in 100%. So in 100%, you can see when the button is not pressed as our condition was supposed to be in backwards direction. You can see the speed has lowered a lot. It is in minus and 1 point or 0 point. It is still decreasing, you know. And what will happen for our speed of the PWM operation? Let's see. It is 0. Okay, the speed is 0 for PWM. So you can take first column as duty cycle, second column as the speed of motor, and the third column speed of PWM operation that you can DC speed control system that you are trying to make. Same operation if we try to use the button, just press it, you will see speed is very low, isn't it? It has almost stopped, the motor has stopped. So now let's try to take the value around 75%. Okay, so you can select this wire and no, it's not moving. So what we can do is just give a minus to decrease as your values are decreasing, okay, going towards 50%. Let's take 75. Okay, let's take 25 difference. Okay, 25 difference values. Let's take 75. Oh, I have gone towards 60. No, I am supposed to take 75. Okay, so let's take 75. As you can see, the motor is in backwards since it is not pressed. Okay, motor is running in backwards direction and it is in minus as well. So it is around 8 point something. It will stop, a static value will come. Let's wait for that time. So what you can understand from the flowchart, we have taken very limited, very small delay time, right? 100 milliseconds. So that's the reason why our speed of the motor and drastic change has occurred. You know, if you take more delay time, let's say in seconds, so what you can learn from here, if you just take the delay time more, if you increase it, then your values will be taken, or the transition will happen using a very long amount of time. Delay will be increased. So you can see the fixed value is around minus 7.45 or something like that. If we press the button, the direction will be forwards. Okay, as you can see, it is trying to be in forward movement. And the speed will be around 7.45 in the positive, clockwise direction. Positive or forward condition, 45, 42, 43, something like that. Okay, not more than that. Okay, as you can see. So now we can release the button and see what is the speed. Okay, so for that, or we can, no, it's not moving right now. I have to release the button, and this, you can see the speed is 64. So as you can understand, for 100%, you can now do one analysis. At 50%, your speed was 128 for the monitor. Okay, final PWM output operation. For 75%, it has decreased to 64. For 100%, it has decreased to 0. So how you are going to take the interval of readings? You will take 0%. Let's reduce the value instead of 50. So what is supposed to be? Okay, if I reduce the value up to 25, let's say 25. I am taking 25 intervals for now, but your task for learning the system efficiently, it would be better if you take 10% intervals. And when you compare the values, the first value, let's say, is for 100%, it's 0. If you take 90%, you will get a value. I will show you when 90% speed is what is happening. So later on I will show you. So let's see 25%, what is supposed to be. The speed is supposed to be increased, right? As you can see, the speed has increased to 192. Along with that, the speed for our motor has also increased. So as the duty cycle, it is vice versa relationship, right? As the duty cycle is decreasing, the speed of your motor, the speed of PWM operation has also increased respectively. So it is minus because the button is not pressed. If I press the button, the direction will be automatically changed and the value will be exactly the same as it was supposed to be for backwards motor direction, motor running. So I hope these things might be helpful for building some knowledge, some basic knowledge for regarding proteus simulation. Many simulations are already available in YouTube. Many videos are already available. Many slides are there already for the students. But I thought maybe if we can design some system like that and just share it with you, all the students, might be. And I will try to upload this video for YouTube as well. I think many students, not only the students of my university, but also other students from worldwide, okay, from any other university can get access to these videos. I think so it will be helpful for all of the students. Anyways, for the learners actually who want to make some projects regarding proteus, I think it will be very helpful. So what is the speed of our display system? Let's see. It is 192. So it has increased, okay, from 50% to, it has increased. So let's increase the value further to 10%, okay. 10% you can take, or 0 also. Since I'm taking 25% difference, so let's deal with 0 first, okay. So the speed is supposed to be maximum. See, the motor has become mad, the speed. So it is just very drastic. It is moving in the speed of a flash, okay. Minus 400 something, 400, I don't know, 450 something it will be, okay. 59, as you can see. So now let's just press the button and see. It will be plus 459, just in the opposite direction, okay. 459. So anyways, now let's see the output for our See, it is maximum is 255. So now let's try to see how it is related with duty cycle or like T on or T off. The formula we have used, one formula 0.25. If you remember, we have used one formula 0.25 into our PWM output, isn't it? So how it is going to, why we are taking 0.25? Now you might have a question in your mind, why this 0.25, why not 0.75 or some other values? It is not because you might think that the answer lies while our operation that I have taken 25 difference. No, it is not the correct answer. The correct answer is, now we can guess our correct answer, okay, or get our correct answer, how it is going to work. Let's see, for 0%. You're going to take 10% differences, as I have already said. It will be helpful if you take 10% instead of 25% intervals, okay? The differences should be 10% for better understanding of this overall PWM operation. So it is 0%, the speed is 255. Let's modify the value, okay? Just vary up to 10%. The video is getting a little bit elongated, but trust me, it is almost over. Okay, the operation is almost over. So as you can see, the speed has decreased to to increase. Okay, not it was supposed to be 255, right? It has decreased, not increased. Actually, it has decreased. I was incorrect. Sorry. I want to explain it again. Our speed was 255 initially. Okay, but now as the percentage of duty cycle has increased, the speed is decreasing. So you can get a vice versa relationship, inverse relationship. Okay, so if you make the difference from 255 to 230, okay, 255 minus 230 is actually 25%, isn't it? 25, the value is 25. That's the only reason why we have taken our formula to be 0.25. Now I guess your answer is almost, many of you have understood. Let's try with another example. Let's increase the value. Okay, remember the values. For 0% it was 255. For 10% it is 230. Now let's take 20% instead of, okay, let's take 20%. So as you can see, 20% it is 204, isn't it? So if you minus from 230 to 204, the value remains how much? 26. So it is nearby 25%. So if you take 30%, you can take 10% intervals. So it is almost, okay, 30%, you can see 179. So if you minus from the previous value, you will get again 25% difference. So that's the reason why only we have taken 0.25 as our value. So I hope this thing is understood by all of you. So now since our overall simulation is done, I hope you don't have any question, the things are clear. But if you have a question, feel free to ask me the questions. Do communicate with me, okay? Communicate with me and ask me the questions that you have in your mind. So I'm going to end our overall system for DC speed control. For now, you can utilize this knowledge for your future projects. I hope and I think it will be helpful for all of you, those who are listening to me right now. Okay, thank you for staying with me, listening to my words so patiently for such a long period of time. As I can see, it is around 49 minutes. Thank you very much, and please utilize this knowledge for future projects. So this is me signing off. I'm just going to turn off the video right now. Okay, thank you very much.